January 15th, 2025. A Falcon 9 rocket lifts off from Cape Canaveral carrying 2 robotic passengers bound for the moon, Firefly Aerospace's Blue Ghost lander, and a Japanese spacecraft called Resilience. The rocket does its job perfectly, flings both landers toward the moon, and then does something almost nobody watching that launch gave a second thought to. Its upper stage, the second stage booster that provided that final push, doesn't fall back to Earth and burn up the way most rocket stages do. It keeps going, caught in a slow, drifting orbit that loops between Earth and the moon. An 18-month journey nobody planned and nobody's steering. Ending tonight in a high-speed collision with the lunar surface that most headlines are covering as a fun light show. It's actually a much bigger story than that, and almost none of the coverage you've seen is telling you the parts that actually matter. I want to walk you through this story the way it actually happened, following this specific piece of hardware from the day it launched to the moment it's about to become a fresh crater on the moon, because the full journey reveals things the quick headline version leaves out entirely. A tracking mistake scientists made just 4 years ago on a nearly identical object. The honest reason nobody is actually going to watch this crash happen live, and a debris hazard finding, buried in the actual research papers that matters far more than whatever flash of light you might catch tonight. Every detail here comes straight from the scientists' own published work and their own words. Let's start at the beginning, back on that January launch pad. If you're planning to try watching tonight's impact yourself, drop a comment and tell me what equipment you're using, because I want you to go in with realistic expectations rather than whatever a thumbnail promised you. And subscribe if you want to follow what scientists actually find once the real analysis comes back in the days ahead, because that part of the story is genuinely more interesting than tonight's brief spectacle. Let's get into it. So, back to January 2025. The Falcon 9 upper stage that launched Blue Ghost and Resilience did exactly what it was built to do. And then its job was simply over. Unlike most rocket stages, which either burn up re-entering Earth's atmosphere or get deliberately deorbited into open ocean, this particular piece of hardware, cataloged by trackers as Object 2025 Pseudo 10D, settled into a wide looping orbit weaving through the gravitational tug-of-war between Earth and the Moon. Roughly 12 meters long, 4 meters wide, and weighing around 4,000 kilograms, essentially the size and mass of a large delivery truck. It just kept drifting, month after month. An inert, silent piece of debris with no engine, no transponder, and no way of telling anyone on the ground exactly where it was. Except somebody was watching. An astronomer named Bill Gray runs a project called Project Pluto, specifically dedicated to tracking exactly this kind of faint, high-orbiting object drifting through cislunar space, the vast region between Earth and the Moon. Over the following 18 months, Gray and observers working with him photographed this specific rocket stage more than 1,000 separate times, each observation a tiny data point helping refine exactly where its slow, looping orbit was headed. Gradually, month by month, that picture sharpened. The Earth's gravity tugged one way, the Moon's gravity tugged another, and somewhere in that gradual gravitational dance, the orbit shifted just enough to put this drifting piece of space junk on a collision course with the lunar surface. Nobody aimed it there. Nobody decided, at some point, this is where it should end up. It got there by accident, the same way space debris often does, and the only reason we know precisely when and where it's going to hit tonight is because of that patient, unglamorous, 1,000-observation tracking effort. Here's where the story takes a genuinely important turn that almost no coverage of tonight's event actually walks you through, and it happened 4 years before this object ever launched. Back in 2022, a very similar piece of drifting space debris struck the far side of the Moon near a crater called Hertzsprung, carving out an unusual double crater, roughly 28 meters wide, and oddly elongated impact scar, suggesting the object had 2 significant masses positioned at either end, unusual for a natural impactor like an asteroid. When astronomers first spotted that object heading toward the Moon, the same tracker behind tonight's predictions, Bill Gray made an initial identification. A SpaceX Falcon 9 second stage left over from a 2015 launch. That call made headlines everywhere. SpaceX rocket debris hits the Moon, the story practically wrote itself. Except it was wrong. As more tracking data came in over the following weeks, Gray went back, re-examined his own conclusion, and revised it. The object wasn't a SpaceX Falcon 9 stage after all. It was, in his updated assessment, far more likely a discarded Chinese Long March 3C rocket body, leftover hardware from the 2014 Chang'e 5T1 lunar mission. That correction barely made a fraction of the news coverage. The original, more dramatic misidentification did, and to this day, there remains some genuine, still unresolved uncertainty within the tracking community about the true identity of that 2022 impactor. It's a quiet, honest reminder that Even careful, professional astronomical tracking of objects loosely drifting through the space between Earth and the Moon carries real uncertainty, and that headlines built on early tracking data can and sometimes do turn out wrong. Why does that 4-year-old story matter for tonight? Because it's the honest context missing from almost every piece of coverage promising you a confidently predicted, precisely located crash. Tonight's object, 2025-010D, is genuinely far better tracked than that 2022 mystery ever was, with continuous, well-documented observations stretching back to its launch rather than a scramble to identify an object after the fact. By the time impact actually happens, tracking data should pin down the exact moment and location to within a few dozen meters, in a fraction of a second. Genuinely impressive precision. But Gray himself has been honest about the caveat almost nobody repeats. Space junk, in his own words, can do some genuinely odd things over the course of months, from subtle solar radiation pressure to unpredictable tumbling that changes how it reflects sunlight. And while a dramatic last-minute shift in tonight's predicted impact point is considered unlikely, it hasn't been entirely ruled out right up until the final observations before the collision. So what's actually going to happen tonight, and what are you actually likely to see? The impact is predicted near Einstein Crater, close to the Moon's western limb as viewed from Earth, striking at roughly 2.43 kilometers per second, about 8,750 kilometers per hour. With no lunar atmosphere to slow it down even slightly, that upper stage hits at essentially its full orbital speed, expected to gouge out a fresh crater somewhere between 20 and 30 meters wide. Here's the part most thumbnails oversell: the actual flash of light at the moment of impact. Researchers modeling this event have been direct that because the upper stage is traveling considerably slower than a natural meteoroid would, and because it's a large, hollow, spacecraft-like structure rather than solid rock, the resulting flash is expected to be noticeably less intense than a comparable natural impact, and likely to last under a full second, even under the best possible viewing conditions. William Joe, a researcher at the University of Texas at Austin who ran detailed physics simulations specifically of this impact, said something in his own interviews that almost none of the viral coverage of tonight's event actually repeats. The flash isn't really the story here. His real concern, in his own words, is that most casual observers will fixate entirely on that brief, likely to be missed flash, and simply stop watching right afterward, never tracking down the part of the event Joe and his colleagues actually consider scientifically meaningful. That part is the ejecta plume, and it's genuinely the more remarkable half of tonight's story. Joe's simulations predict the central column of debris thrown skyward by the impact could reach somewhere between almost absurd height for material launched by a single collision. Because the predicted impact site sits close to the boundary between lunar day and night, as seen from Earth, sunlight could catch that rising debris column at a favorable angle, potentially lighting it up against the surrounding darker sky enough for sufficiently sensitive telescopes to actually catch it. Joe has described his modeling as producing a plume that should be several orders of magnitude brighter than the dark sky background for the first few minutes after impact, though he's careful to add the caveat most coverage strips out entirely. This is one simulated nominal case. The real thing will almost certainly look somewhat different, and his numbers skew toward the optimistic end of what's actually likely to be observable. And here's a detail that genuinely surprises most people once they hear it. No spacecraft is going to actually watch this impact happen. NASA's Lunar Reconnaissance Orbiter, the spacecraft best positioned to eventually document tonight's crater, isn't parked in position waiting to film the collision live. Brent Gary, a project scientist working on the LRO, mission at NASA's Goddard Space Flight Center, has explained that the orbiter will pass over the predicted impact zone roughly 7 days before tonight's collision, and again roughly 7 days after, comparing before and after imagery to precisely locate and characterize the resulting crater. That means the actual confirmed picture of exactly where this thing landed and what the fresh crater looks like won't fully exist until roughly a week from now, once that second LRO pass gets analyzed. Whatever thumbnail promised you a live, confirmed orbital view of tonight's actual crash is, quite simply, promising something that isn't technically happening. Now, here's the part of this story that deserves the most attention and gets the least. A separate research team, led by Benjamin Fernando at Los Alamos National Laboratory, modeled not just the visible plume from tonight's impact, but the complete ballistic spread of debris material this collision is going to scatter across the lunar surface. Their finding: the maximum ballistic range of resolvable debris particles from tonight's crash extends to just under 1,000 kilometers from the impact site. Not meters, kilometers. Fernando and his co-authors described that range, in their own published words, as far enough to be significant from the perspective of presenting a hazard to future astronauts or infrastructure across much of the lunar surface. Sit with that sentence for a second, because it's genuinely the most important line buried inside this entire story. NASA's Artemis program is actively working toward returning astronauts to the lunar surface and building permanent infrastructure there within the coming decade. Every discarded rocket stage, every spent lander component, every piece of hardware finishing its mission and left drifting in orbit around the moon the way this Falcon 9 stage was for 18 months, represents a genuine physical hazard to that future, not through some dramatic head-on collision with an astronaut, but through exactly the kind of high-velocity ballistic debris field tonight's impact is about to demonstrate in real time, in full public view, essentially as a live-fire test of a problem nobody's actually solved yet. And here's the part. Almost none of tonight's viral coverage brings up. There is currently no established international framework, no clear governing authority, no agreed set of rules specifically dictating who tracks, manages, or mitigates exactly this kind of debris hazard in the space around the moon. Earth orbit has, imperfectly but genuinely, built decades of tracking infrastructure and an increasingly serious international conversation around orbital debris. Cislunar space, the exact region where tonight's object spent the last 18 months quietly drifting toward this collision, has essentially none of that yet, even as commercial landers, government missions, and eventually permanent human presence rapidly increase traffic through this exact stretch of space. This isn't manufactured concern for dramatic effect either. It's literally the stated framing multiple of tonight's own researchers used in their published work. Fernando and his team explicitly describe this event as a genuine opportunity to study, in their words, hazards from artificial space debris, impacts that future astronauts on the lunar surface might have to avoid. That's not speculative alarmism. Dressed up for a video script. That's the actual, stated scientific purpose driving serious researchers to study what would otherwise be a fairly minor, if visually interesting, one-off collision. Zoom out for a second, because tonight's crash isn't happening in a vacuum, historically speaking. Human hardware has struck the moon before, both by accident and on purpose. Back in the early 1970s, NASA deliberately crashed the spent upper stages from the Apollo 13 through 17 missions into the lunar surface, using the resulting artificial moonquakes to help calibrate seismometers left behind by earlier landing crews. A genuinely clever bit of scientific opportunism using hardware that was going to hit the moon regardless. In 2009, NASA deliberately steered a spent upper stage into a permanently shadowed lunar crater specifically to kick up material a trailing spacecraft could analyze for water ice, a mission that ultimately confirmed water ice really does exist inside those permanently dark craters. What actually sets tonight's event apart scientifically isn't that it's happening, it's that researchers had unusually long advance notice, enough lead time to plan detailed observations of what is otherwise an entirely accidental, unplanned impact using a piece of hardware nobody designed to hit the moon on purpose. Scientists studying this event have pointed out there are, in their own words, very few existing impact models for human-made, hollow, spacecraft-like objects, as opposed to solid natural impactors like asteroids and comets. And tonight's crash offers a rare chance to calibrate those models against a real, observable event. Data that will directly shape planning for every future piece of hardware humanity sends toward the moon, intentionally or otherwise. So here's the full, honest version of the story you're actually about to witness tonight, stripped of everything, built purely for clicks. A discarded rocket stage that finished its job launching 2 lunar landers 18 months ago drifted, entirely by gravitational accident, onto a collision course with the moon. Astronomers tracked it with genuinely impressive, though not infallible, precision, using nothing but repeated optical observations of a small, silent, faint object, a tracking method that got a very similar object wrong just 4 years ago before eventually correcting itself. The visible flash, most coverage is hyping is uncertain, likely brief, and faint, and easy to miss even for people actively watching. The far more scientifically important part, the towering ejecta plume and the nearly 1,000-kilometer debris field this collision is about to scatter across the lunar surface, is the actual reason serious researchers care, because it's a live, real-time preview of a debris hazard problem that's only going to get more urgent as human activity around the moon accelerates in a region of space that currently has no real governing framework for managing exactly this kind of risk. If you're going to try watching tonight, go in with honest expectations. This isn't a naked eye event. You'll want a telescope with genuine light-gathering capability, ideally paired with a sensitive camera, precise knowledge of the predicted timing and location, and a willingness to accept that even the researchers who modeled tonight's plume have admitted their own numbers lean optimistic. If you miss the flash, or if it turns out fainter than predicted, you haven't actually missed the real story. That story unfolds over the coming week, once NASA's Lunar Reconnaissance, Orbiter makes its follow-up pass, confirms exactly where and how big the new crater actually is, and hands scientists the data that genuinely matters for understanding what humanity's fast-growing footprint around the moon means for the astronauts who are going back there next. We'll keep following this story as LRO's follow-up imagery comes in and researchers publish what they actually find. If this filled in the gaps the quick version of this story left out, subscribe so you catch that follow-up when the real data lands. Drop a comment if you're attempting to watch tonight yourself and let me know how it goes. Stay curious, stay informed, and I'll see you in the next one.